A cylinder of radius 8 cm rolls 20 centimeters in 5 seconds without slipping. Through how many degrees does the cylinder turn during this time? So, let's draw the picture to understand the problem. So, we have a cylinder and it looks like this somewhat, right? So, it is rolling and the distance it travels in 5 seconds is 20 centimeters, and the radius of the cylinder is given to you, which is 8 centimeters. So this radius is 8 centimeters. So as it is rolling, so it's completing one circle. It's starting from a point, it's rolling and coming back to the same point. So that is one circle. So we need to find out how many such circles or how many such revolutions has it completed when it rolls the full distance of 20 centimeters. So to find that, what we have to do is we need to calculate what is the amount of distance it covers for one revolution. So for one revolution, the distance that it covers is equal to the circumference of the cross-sectional area of the cylinder, which is a circle. So we know that the circumference of the circle is given by 2 pi r. So we can write 2 times 3.14 times the radius. In this case, the radius is 8 centimeters. So let's take 8 centimeters. And if we multiply that, we get 50.24 centimeters. So that is the amount of distance it covers if it goes for one full rotation. All right. Now the distance that is given to us is just 20 centimeters, which is of course less than the total circumference for one full rotation. But even then we can calculate. So number of revolutions, it will be in fraction. It's not going to be a whole number, or it's not going to be more than one. So the number of revolutions completed when it is traveling a distance of 20 centimeter is going to be, so we need to divide 20 by 50.24, and that is going to be 0.398 revolutions. All right. Now the question says, through how many degrees does the cylinder turn during this time? So during this time, if it is completing 0.398 revolutions, so we know the relation between revolutions and degrees. So one revolution equals 360 degrees. So if it is 0.398 revolution, it's going to be 360 times 0.398. And if you multiply that, that is going to be 143 degrees approximately. So your answer is going to be 143 degrees. The diameter of the moon is 3.47 times 10 to the power 6 meters, and it subtends an angle of 0.00904 radians when viewed from the surface of Earth. How far is the moon from Earth? Now let's draw the diagram. We know that the moon is a satellite of Earth and it revolves around the Earth every 28 days almost. So say this is the moon. All right. So we need to understand how far is the moon from the Earth if the rest of the items are given to you. So you have been given the diameter of the moon. So let's draw it a little more in detail. So we have the Earth here and we have the moon here. Diameter of the moon is given to you, which is 3.47 times 10 to the power 6. All right. And that is subtending an angle at the Earth's center. And this angle is given by 0.00904. 0.00904 radians. So you need to find out what is this distance, like how far is the moon located from Earth, right? So if you look at this diagram very closely, you should be able to understand that basically they have given you the angular displacement theta, which has a value of 0.00904, and this is almost equal to an arc length, which is the diameter of the moon, 3.47 times 10 to the power 6. And they are basically asking you to find out the radial distance of the moon from the Earth. So we know this equation, S, the arc length, is equal to the radius times the angular displacement theta. So if you put all the values over here, so S is basically 3.47 times 10 to the power 6, and that is equal to R times the angular displacement, which is 0.00904. 0.00904. All right, so if you divide it, you get 3.47 times 10 to the power 6 divided by 0.00904, and you get a value of 383.84 times 10 to the power 6. And that is the distance of the moon from the Earth. So that is your answer.